pleasure to welcome back to the F Team podcast, Nathan Kettle. Welcome back, mate.
Thanks for having me yet again. It's a pleasure to be here, and it's always good to see your face, buddy.
Likewise. Hopefully we can see each other's face in person more regularly.
It's getting more real by the day.
Little carrot on the stick for us. So before we get into the content, a little birdie told me that you were recently bestowed a very prestigious award at Fast Track. Tell us about it.
Yes. We had our Christmas Day last week. For those of us here in Melbourne, and was bestowed upon me the award of never late for happy hour drinks. And I would like to think that is off the back of my punctuality, my work ethic, and my ability to overachieve, and nothing to do with my propensity to prop up the bar.
Mate, it's a very important job. Someone has to do it, and you do a fantastic job. So keep it up. Keep it up. Hopefully you can continue to hold that mantle next year.
Well, the challenge has been thrown down, so it's up to everyone else to come up to the level.
That's right. Now, in 2020, the computing hardware space has been filled with many disruptive and game-changing moments. Some of our favorite computing companies have been hard at work to keep the advances coming, despite the challenges thrown at them all year. This is definitely true for California-based semiconductor company Advanced Micro Devices, better known to you and I as AMD. Since Lisa Su joined AMD in 2014, the company has undergone a massive transformation, and some even say they've entered a golden age of innovation. This year, AMD announced the Zen 3 core, which is a ground-up redesign. Some are saying that AMD has finally and fully eclipsed Intel's performance dominance in desktop PCs. Nathan, why are we talking about AMD's Zen 3?
Well, AMD themselves have been referring to the Zen architecture as disruptive since 2017. And many pundits didn't quite see it at the time because they were coming from so far back with their previous bulldozer and excavator architectures. They floated a 40% IPC increasement for their first generation Zen. They not only met that, they exceeded it. They hit 52%, which is a massive uplift, and it brought them back within the ballpark of Intel. But for single-threaded workloads or lightly threaded workloads, they weren't quite there. They had some memory latency problems just with the way their memory architecture worked. It was awesome for multi-threading and high throughput, but when it came to short bursty workloads, they were a little bit behind there, and they had some catch-up work to do. And they've iterated since then, each generation from Zen Plus through to Zen 2. We saw Zen 2 come really, really close back last year. And this year they iterated again. Most of the changes were down to the actual architectural level. So the node didn't change. Both of these, Zen 2 and Zen 3, are on the 7 nanometer TSMC process, which is pretty close to industry leading. There are obviously more bespoke nodes such as Apple are on the 5 nanometer, and Intel's 10 nanometers, technically around about the same size, but it's so ambitious they can barely get it off the ground. So this is kind of why we're talking in a sense about Zen 3, is because it works. It's in the market in full sort of force. It's not just sort of like a mobile space thing like 10 nanometer Intel is. So they redesigned over Zen 2 with changes to branch prediction, which increases efficiency. They changed the way it executes the data flows, and also they unified the cache on their CPU so that the memory access is more uniform across the cores, because previously their architecture, the caches were split between different CCX modules. So in a sense, everything sort of came together finally. They built the building blocks each time, improvement upon improvement each generation, and now what we're seeing is that this is how, if you had the time and the money, the 10 years of 5 to 10 years of development that a CPU can take to reach, full sort of operational capacity. We're seeing that moment where we've got a mature process node in the TSMC 7 nanometer architecture. They've iterated upon their previous designs and improved in the parts where it wasn't so great, and enhanced the parts where it already was. And it all come together with improving the memory subsystems so that memory latency sensitive workloads are vastly improved.
So are we, just a question without notice, what's your view? Have they, is this a product that is putting them on the tier one, the top of the range processing scale, or is it, what's your view?
For probably 90 to maybe 95% of the possible workloads that I'm aware of, there are a lot of different workloads. There are thousands, tens of thousands of different applications and specific bespoke workloads. But for most of the main ones that anyone could care about, yes.
It's a pretty big statement.
The IPC uplift on Zen 3 was just as significant. It's anywhere between 15 to 25% on the extreme end on some, but you can bank at least on average a 19 to 20% IPC uplift. And now for those who are uninitiated, IPC is instructions per cycle or instructions per clock, because the clock cycle is one and the same thing. So it's each tick of the processor, how much work gets done.
Right.
So you can make it run faster or you can make it work harder. It's kind of like the same as the difference between horsepower and torque. Horsepower is the rate it gets done at, and torque is the amount of force that's applied. So by increasing IPC, you can actually drastically improve the amount of work that a processor can do without increasing the power like you would with increasing clock speeds. So the IPC is a really important thing that's really difficult to measure. And it's really difficult to publicize in a lot of respects because you don't have an IPC benchmark. You just have benchmarks and you look at the clock speeds versus the power to see what the difference there is. So it's a rising tide that lifts all boats, as Lisa Su likes to put it. And it's brought the company a long way. And in my book, it's put them ahead of Intel, not just for outright performance, but also performance per watt.
Yeah, right. So is that the biggest disruptor of this, just the overall performance of this piece of technology, or is there something else about it that's worth calling out?
Yeah, there are further considerations on top of that, and it's not just bespoke to Zen 3; it's across the entire Zen family, from Gen 1 to this third gen or fourth iteration, and that's the fact that they managed to bring high density core counts to computing. On desktop previously, you had quad core processors, and if you're lucky, they had hyperthreading if you got an i7. Which is around equivalent to about 6 cores when you got 4 cores plus hyperthreading or thereabouts. And it wasn't until the first generation Zen came along and brought 8 cores to the desktop, which was previously solely the realm of high-end desktop, which was very expensive, and servers. So they brought a lot of compute power to the people. And not just then in the desktop space, in the mobile space, they brought 8 cores to mobile, which if you had told someone when they bought Skylake back in 2016, which was the top of the line Intel i7, that my laptop in 2019 would have double the cores of your most powerful desktop, you'd get laughed out of the room. So this is where they disrupt. They disrupt in core density, in power per core as well, because they're able to offer 8 cores at a similar power envelope to the quad cores, and also price. They competed really heavily on price. The prices, of course, have risen as they've gotten closer and closer. And then, of course, in the server market, they've super high density core counts. They've been spitting out 64 core chips in the server market since first generation Zen. 64 cores on the high-end desktop in Threadripper, which was previously 32. So Intel had been stuck around, like realistically around the 24, 32 core mark in the server market, and AMD are able to ship 64 to the high-end desktop. So this is where the disruption occurs. They've completely upended roadmaps, companies' roadmaps that said we'll produce this, and this for the next 5 to 10 years. A lot of other companies are having to adjust and having to come up with scramble plans basically to match it. I know Intel have got a dual die CPU in the works for their next generation. So that's not one processor, that's sort of 2 on the one substrate, which they gave AMD a lot of shtick for when first generation Zen came out, and they took the mickey out of them quite harshly and aggressively because they called it a glued-on processor, and now they're doing very similar things with the EMIB technology for their active substrates. So it seems to be the way of the future, and AMD got on it nice and early. They in fact pretty much led the charge on it. So yeah, this is why I think it's very accurate for AMD and Lisa Su to call it a disruptive technology.
Totally. It's such a power play. And I think we're going to be feeling the ramifications of this announcement for many, many years.
And it's not just from their end, it's given Intel a massive kick in the pants.
Yeah.
They were coasting along without any competition. They started working on 10 nanometer probably in 2015, and it's at least probably somewhere around 3 or 4 years overdue, and it's still not in market properly. It's in mobile, in quad-core mobiles, but that's all they can make out of it. The failure rates are too high on larger core chips. So we anticipate Intel will get their act together in the next year or two, and manage to produce either 10 nanometer or 7 nanometer parts of their own. But the ramp up takes time. They're pretty much stuck mostly on 14 nanometer for a while. And don't get me wrong, 14 nanometer is a very venerable node. It's done them very well. And because it's so long lived, it's had this sort of balance in the market where people like app makers and program makers, they know what it does. They know how it works, so they can optimize for it very easily. And it has been optimized across most of the work platforms to run properly and be validated. So in a respect, that's kind of like done them a very big solid, and they've been able to just optimize to get the best out of it. So it hasn't all been bad. It's just when you're coming up against core density and power density limits, when you're filling out a rack of servers and you've only got X amount of kilowatts to sort of put out there, when you're stuck on 14 nanometers and probably sucking a little more juice than you need to, if you're on a more efficient node, a newer node, then it can create problems. So the next few years will be very interesting in to see how far Intel can come back. And don't get me wrong, they will. They're not just going to go, oh, well, what are we going to do, sort of thing. They're going to do the things they need to do, but the ramp up is just going to be what takes time.
And we're the ones that benefit, right? The businesses.
Oh, of course. So, like, you haven't been able to wipe the smile off my face for the last 2.5 years, because the space is vibrant again. There's competition, there's improvements, and the consumer's usually the only one that benefits. Not like the GPU space, where we've finally seen decent improvements, but we've seen massive price hikes to sort of counter it. Whereas the CPU space has been a little bit more conservative on the price hikes to the performance, just purely, I would guess, just because it's such a high volume area. Whereas the GPU space is, compared to CPU, is a much lower volume.
Yeah. And so this is lining up an exciting 2021, right? So like, I'm thinking the 11th of January is the time where we're all going to get very excited, and that's because manufacturers usually launch the mobile lineup at CES on that date. So, Nath, what are we predicting the impacts that AMD Zen 3 will have on the laptop market?
Well, if we base it off the improvements that Zen 2 brought, so we're still on Zen 2 in the mobile space in the 4000 series. They were able to either match or fall very close, or in some cases beat Intel's 10th generation laptops, the 10 nanometer parts, which is pretty much the best that they can put forward right now, other than the 14 nanometer parts with the 10 nanometer back ports of the designs, which also are quite good. Intel fired back more in the integrated GPU space. Intel's integrated HD graphics have been anemic and weedy forever, basically. They're good enough for video out, and that's about it. So, accelerating workloads in Adobe. I hear you guys in the background. Yep, I hear you. So, one of the big sort of knocks on it was that it wasn't very powerful. And AMD, of course, had their APU options where they had integrated graphics from their GPU side. So the integrated Vega and soon to be integrated Navi graphics architectures. So that was where AMD shone. If you needed an APU that could handle some light graphics workloads, that was really handy. And it didn't use a lot of power either. It was really in the same power envelope as their CPUs. So it was a really cool product. And Intel have been working on their own GPUs, like the Intel Z graphics, which they're starting to integrate into their platforms. So that's been really, that's been cool that Intel have been able to do that, so they can match AMD on that side. So there's this sort of race between the two as one catches one in CPU, the other one catches the other in GPU, which means that they're sort of on level pegging at the moment. And AMD know the 11th gen Intel are coming. So by getting their 3rd gen into mobile early next year, or as soon as they possibly can, with the way the global situation is with manufacturing and supply, there might be some delay. It might not be. It might be announced at CES. We might not see them for a little while, but when we do have more concrete information and we do know when these things are going to start hitting the shelves, we can start to really get excited, because the uplifts that I've already spoken about from Zen 2 to Zen 3 on the CPU will immediately translate to the mobile space. So you'll see clock speed increase, IPC increase, memory bandwidth, memory latency sensitivity improved, as well as power envelope. So that's the one surprise factor that everyone saw with Zen 2 in mobile space, is that it absolutely canned Intel's 9th generation for power and performance per watt. So you had 8-core AMD mobile processors operating at 25 watts, beating the Intel 8-core processors running at 45 watts. So massively improves battery life and same or better in some cases performance. So they're really killing it in the mobile space, and that's where the real battle is, because that's where the sales are. That's where the big sales are for volume, is mobile. So the mobile battle that we'll see next year is going to be a doozy, because you're going to have AMD bringing their best, you have Intel bringing their best with their 11th gen, and it's going to be on. Like this year it was on, and it's only going to step up another gear. So it's like going from the 2nd round of Mike Tyson versus Evander Holyfield into the 3rd round, and just like it's just going to get better, and I can't wait to see.
I was going to make the reference. It's like watching Lord of the Rings, Fellowship of the Ring, and then watching the Two Towers. But
that's same. Like it's literally the same thing.
Yeah.
I can't see the difference.
Yeah. Listening to all this, you know me, I'm the marketing guy, right? So I'm thinking, okay, well, as a consumer or as a business owner, or even as a IT manager that's considering a device fleet and where to invest their energy and obviously when they're upgrading their funds, why would I be looking to buy something with a Zen 3 based laptop or desktop over at Intel like today?
So if you've got sort of core heavier workloads,
Yeah.
if you're finding that you're running on a quad core laptop and you're quite often, the CPU's pegging quite high, the usage is quite high, it's getting a little sluggish, you're sort of reaching the limits of the productivity that the 4 cores can give you, then the 6 and the 8 core options in the AMD mobile laptop space are just, they're the logical next step. You can't really go any higher at the moment on the Intel platform. You're stuck with your quad core hyper-threaded 10 nanometer parts. AMD have got some really cool technology. Even in Zen 2, they brought in Smart Shift, which is a technology that can actually allocate the power, but the overall power envelope of the laptop to where it's needed. If you're doing a lot of work and it's requiring a lot of CPU, it can move more of that power budget over to the processor to get that work done and keep its clock speeds higher and let it run in a higher power state. Or if you're conversely, say you're playing a game or you're doing some rendering on the GPU or some, whatever parallel workloads there, and the GPU is demanding more of the workload, it can shift that power back to the GPU to increase where it performs at, rather than raising and lowering the two in unison. It's now they can be moved independent of each other. So that's a really cool way of not just saving battery life, but increasing performance, keeping temperatures down when needed. So instead of ramping the CPU and the GPU, it's just one. So it's got some good implications for thin and light laptops, and also for power use laptops. Like it applies everywhere. So yeah, they've just really brought some good game, and obviously their mobile laptops have a little bit more powerful GPU in them, although Intel are catching. So the interesting part of the equation for Zen 3 and mobile, will AMD bring in the Navi cores, which their current new desktop GPUs run off, which are exponentially more powerful than the Vega graphics that they've been using, which go all the way back to, I'd like to say, about 2018. So that would be really cool if they could start including some Navi cores to counter Intel's sort of foray into the GPU space with Intel Z graphics. So we've just got to wait and see what happens after Christmas, and maybe we'll have another Christmas in July.
I'm gonna say it's a late Christmas present that we can look forward to.
Any day is Christmas if you're brave enough.
That's right. They're using 2 different generations of Zen chips in some of these designs that we're talking about. So why in the laptop space would they be using 2 different? Why wouldn't they use the latest generation of chip?
So it's mostly down to yields from the fabs, the places that make the silicon and the chips themselves. So at the moment, there's actually kind of a worldwide shortage on 7 nanometer capacity, because you've got AMD running their desktop CPU on 7 nanometer, their server CPU on 7 nanometer, their high-end desktop CPU on 7 nanometer. Their previous generation mobile, being Zen 2, is on 7 nanometer. Their GPUs are all on 7 nanometer. TSMC's 7 nanometer process is just in such high demand right now, and there's only so many fabs. So we didn't see AMD move to 7 until Apple left it, because Apple, well, they were on it for their GPUs, but I mean for their CPUs, since we're talking about processors here. So when Apple made the move from 7 nanometer TSMC to 5, that freed up a lot of fab space, and it was just in time for Zen 2. Right. Just in time. Like, if Apple had have dilly-dallied, then it would have delayed Zen 2.
Makes a lot of sense. A very holistic way of launching a product. I guess they've had lots of practice, right?
Well, they're only 1 year younger than AMD.
Yeah.
I mean, Intel, sorry. AMD are only 1 year younger. So both of those companies were essentially spawned out of Fairchild Semiconductor back in the 70s. So they're not that far apart, these siblings.
So it's a very interesting sibling rivalry to watch.
Yes.
And, there's lots going on in this space. So
and we haven't even talked about Team Green. So no NVIDIA talk here yet.
No, exactly. Well, let's save that for another webinar, eh?
Let's book it in.
Yeah, let's do it. I think that's all we've got time for. So thanks for this, Nate. It was really informative. Looking forward to touching base after CES and seeing what comes out of that. And also...
I want to chuck a thanks in there to Aaron for finally allowing me to talk about Ryzen. After a whole year of, you can't talk about Ryzen. You can't talk about Ryzen. I'm like, I just want to talk about Ryzen. Let me talk about Ryzen. I'm fanboying a little bit over here.
No, it's good. I love it when you fanboy. Very good. And the other thing I'm keen to get you to talk about another time is the Epic server as well, which could be a very good topic and potentially a bit more relevant to some of our infrastructure managers that might be listening. So
of course, especially once they make the move to Zen 3 as well. Yeah. That'd be okay. Just a shiver thinking about it.
Hold your horses, mate.
My horses are getting away again.
This year's been massive for everyone at Fast Track, but one of the things we've enjoyed most is actually hosting this podcast. So I really appreciate all the listeners who've joined us to make this podcast a success. Really appreciate all the speakers who've joined me this year as well. We've covered so much, really aimed to create a really diverse series for everyone and cover lots of different areas in the IT space. So we've managed to cover everything from Microsoft 365 updates. I've discovered a newfound respect for data backups, and we've managed to talk about data breaches in government, in other organisations as well, and we've even managed to fit in a few sledges and Telstra, which was always nice. Really thank you for joining us. Make sure you tune in 2021. We've definitely got a whole bunch of topics planned for next year. So please join us next year. One thing before we sign off for 2020, this is the last podcast. If you're looking to learn more about Microsoft Teams voice calling solution, so that's basically turning your Teams application into your cloud telephoning platform. We've just finished a webinar. It's on the website. Just go to the homepage and you'll find it. Go check it out. Really, really valuable content. It's about an hour and 10 minutes worth of content. Really, really punchy, high production content. So I hope you appreciate it. If you want to learn more, there'll be a link in the description of the podcast and in the video. So make sure you join us for that.